Our last quadrilateral is the kite. A kite is a quadrilateral with two pairs of adjacent sides that are congruent. So the properties of a kite are that diagonals are perpendicular, one pair of opposite angles is congruent, and one of the diagonals will also serve as the line of symmetry for the kite. This diagonal is going to bisect the other diagonal and the opposite angle. Let's take a look at an example. Okay, so if our diagonals are perpendicular, then these are going to meet at a right angle. All right, so that's example one, measure of angle 1 is 90 degrees. Now the measure of angle 2, okay, so let's see what we know. The diagonals are perpendicular. One of the diagonals serves as the line of symmetry. One pair of opposite angles are congruent. And let's see, the diagonal bisects the other diagonal and opposite angle. Okay, so this diagonal is going to bisect this angle, and so if this little piece on the left is 27, then this little piece on the right is also 27. Those are congruent angles. Okay, so if I want to find the measure of angle 2, well, let's just think about this being a triangle, and we know that the three angles in a triangle add to 180. And so we've got 90, 27, and then we just need to subtract from 180 to find this guy. So 90 plus 27 is 117. If I subtract from 180, that's going to give me 63. So the measure of angle 2 is 63. In example 2, we know that SE is 7. Okay, and let's find out. Oh, I put that in the wrong space. SE is 7. Okay, so we know that the diagonals are going to, they're perpendicular, so I already have the right angle. The diagonal bisects the diagonal and the opposite side. So we know that this is also 7 from SI because it's this segment here is being bisected by this diagonal. So each of these is 7. Let's figure out what KS is. Okay, we also know that KI is 25. Wait, what? Yeah, KI is 25. Wow, this is not really drawn to scale, is it? I guess, I don't know. Okay, so we want to find what KS is. So let's go ahead and let me highlight this so I can see my right triangle. I know this is a right triangle because the diagonals are perpendicular. So there's my right angle. This leg of the triangle is 7. The hypotenuse is 25. I need to solve for this guy. I'll call him x. So x squared plus 7 squared is equal to 25 squared. And I think I'm just going to take this to Desmos because these are some big numbers that I can't do in my head. So 25 squared minus 7 squared. 25 squared, I think that's 625. Yeah, I could have done it in my head. Okay, but I don't know what the square root of 576 is. So 24. All right. KS is 24. Example 3. So measure of MNO. that is, this angle here is 72. If I know that the whole thing is 72, if I cut that in half, that's going to give me 36 and 36. I don't know if I need that or not, but I'm going to go ahead and just do that. OLM, this angle here is 98. So cut that in half, that's 49 and 49. And I know I've got right angles all the way around this guy because they are perpendicular. All right, so what else? I'm trying to find the measure of MPN. M to P to N? Well, that's easy. That's the 90 degree. M, now let's find M to L to N. Oh, I already found that. That's 49 because that angle is bisected. And the last one, let's find L to O to M. Okay, so that one I don't know. But if I take this little triangle, and I'm looking for this angle right here, that's the LOM angle. See, I've got a little triangle, and I've got one angle's 90, one angle's 49. Let's add those together, subtract from 180, and we'll get this guy. So 90 plus 49 is 139. If I subtract that from 180, I'm getting, what did I do? What did I do? How about just 51? And how about, let me see, did I do my math right? Oh my goodness, that's terrible. Sorry. Make that a 7. How about 41? Wow, sorry guys. It's late on a Friday afternoon. Oops. Okay, so here are all our different quadrilaterals. And the ones that have no parallel sides, no pairs of parallel sides, would be your kite, your trapezoid. One pair of parallel sides would be, well, a quadrilateral. Let's just call this guy a quadrilateral. It's got 4 sides. No pairs of parallel sides, that would be a kite. Then we have the trapezoids that have 1 pair of parallel sides. We have also the isosceles trapezoid. We have our parallelogram that have 2 pairs of parallel sides. We have the rectangle. We have, this guy is our rhombus, and our square.